Let's take a look at this unit. We'll start with quadratic functions. And the first form we'll take a look at for quadratic functions is what's called vertex form. Some books call this the standard form. Actually, standard form is what I'm used to seeing it as. And it's of this form. F of x is equal to a times x minus h squared plus k. And if you got in that form, if a is greater than 0, then your graph opens up. If a is less than 0, then your graph opens down. Your vertex, which is your highest point or your lowest point, is hk. Your axis symmetry, label that AOS, is x equals h. And your min, now you have a min if your graph opens up. So that's when a is greater than 0. Or your max, and that occurs when your a is negative, when a is less than 0, is going to equal to k. Let's take a look at an example of that. We got f of x is equal to 3 times x plus 1 squared minus 4. Now let's find all the different components. First, let's talk about whether it opens up or opens down. Now a is whatever number's in front of your parentheses here. So a is 3. Now if there's no number here, it's by default 1. Now that's positive. Since a is greater than 0, that tells us our graph opens up, like this. Now, whatever number's inside here, this is going to be our h, and it'll be opposite sign of whatever's there. So h is going to equal to -1 since this is a positive one. And then whatever number's here at the end will be your k. So k is equal to -4. If you're wondering why is it opposite sign, well, whenever your formula has a minus or a negative in it, that always flips your signs. So our vertex is going to be hk. H was -1 and k is -4. Our axis symmetry is x equals h. Well, h is -1. So we got x equal -1. Now our graph opens up. A is positive. So down here, a is positive, then we're going to have a min. It's going to equal to k. So our min is going to equal to -4. So there's our vertex, there's our axis symmetry, and now we have our min. Now let's take a look at the graph. -1, -4. That'd be right there. And that's our vertex. And we know the graph opens up, so that kind of gives us an idea what it looks like before we begin. We need to plot one point. Now usually you choose 2 units away. Like 0 would probably be a poor one to choose because it's too close. But 1 would be a good choice, because our vertex is right here at -1, so that's 2 units away. So we're going to plug in x equals 1 into our original problem and figure out what y is equal to. Remember, f of x is the same as y. So we got y is equal to 3 times 1 plus 1 squared minus 4. 1 plus 1 is 2, 2 squared is 4, times 3 is 12, and 12 minus 4 gives us 8. 2, 4, 12, 8, yeah. So we're going to plot the point 1, 8. Now if you go too far away, if you go more than 2 units away, it's going to be too many. You'll be too far up, too far down, whatever you're looking at. 1, 2, 3, 4, 5, 6, 7, 8. So that'd be 1, 8. Now quadratic functions are parabolas. They have a U-shaped graph. So my graph's going to look like, more or less, this right here. Now our axis symmetry is x equals -1. That means we're going to have a invisible line here at -1, vertical. I didn't draw that very well, but make that a little bit bigger. It's symmetric, this line. What that means is after you get one side of your graph, you can flip it over, reflect it over, and you have your other side of your graph, which will look like that. Now that's if you're trying to sketch it by hand. If you're using a calculator, you go to your y equals, clear, and then do 3, and then begin in parentheses, x plus 1, close parentheses, the x squared, minus 4, and then graph. And that gives us our graph. Now that's a vertex form. Let me clear this off. Now there's a method for writing our general form into vertex form, and it's not necessarily an easy method. I'm not going to write down the steps for it, but let me just give you an example. If you have f of x is equal to 2x squared plus 4x minus 1. And you want to put this in vertex form. I guess I could write down the steps. I don't think it'll take that long. This is still quadratic functions. This is going from what's referred to as general form to your vertex form, or standard form. Our first step, we're going to factor out the number in front of the x squared from the first two terms. This is assuming it's in standard form. Okay, what we mean by that is we look at our first two terms here. We're going to factor out the number that's in front of the x squared. So we'll factor out a 2. And that gives us x squared plus 2x minus 1. Step 2. We want to take the number in front of the x, multiply it by 1/2, square it, and then add and subtract that number inside the parentheses. Well, the number that's in front of our x is a 2. And we say we'll multiply by 1/2 and square it. 2 times 1/2 and square it. 2 times 1/2 is 1, and 1 squared is 1. And then add and subtract that number inside the parentheses. So we got f of x equal to 2 times x squared plus 2x plus 1 minus 1. So not only add it here, but we also subtract it. That may seem weird. It's like, why would you do that? Well, 1 minus 1 is 0, so it doesn't actually change anything, but we're going to see in the next step where that's beneficial. Now, we're going to group the first three terms together and last term by itself inside the parentheses. So step 3, group the first three terms together and the last term by itself inside the parentheses. Now when I say group them, just put a line underneath them like you see what I did right here. Then we're going to factor the first group. So factor the first group. This factors as x plus 1 squared minus 1. Now, there's a trick to that. Whatever number's right here, sign included right before each squared, is always what goes right here. So there's no factoring involved. Now remember, we factored out the number in step 1. So step 5, multiply the number that you factored out in step 1 by both groups. What that means is we're going to take 2 times our first grouping here, this x plus 1 squared, and we'll take 2 times the second grouping, which is negative 1. And then that minus 1 will carry it down. And then step 6, simplify any numbers at the end. And what I mean by that is we have 2 times negative 1, which is negative 2 minus 1, which gives us 2 times x plus 1 squared minus 3. And this would be our answer. That's the vertex form, or standard form. Now I might say, well, that's not too bad. Well, I picked an easy one. I picked it such that when I factored a 2 out, I was left with an even number here. It's when you have an odd number it becomes nasty. Or if you start out with 2x squared plus 5x minus 1. When you factor a 2 out, it becomes kind of strange. This becomes 5 over 2x minus 1. So they're not all as nice and easy as the one I'm showing here. Now this is writing it in vertex form. Now we found a vertex for a parabola by using the no, we haven't done that yet. Okay, I should read it closer. It says the vertex formula. So let's talk about general form. For our general form, it's the form f of x is equal to ax squared plus bx plus c. If you have it in this form, if a is greater than 0, then it opens up. If a is less than 0, your graph opens down. So that's the same as what we talked about before. Your vertex is going to be negative b over 2a and f of negative b over 2a. Your axis symmetry is going to be x equals negative b over 2a. And your min, and that's when your graph opens up, or your max, and that's when your graph opens down, is going to equal to f of negative b over 2a. Now that vertex formula you see right there is actually referred to as your vertex formula. It's got a very clever name. And it's got 3 steps. Step 1 is to identify a and b. Step 2 is plug the values from step 1 into negative b over 2a and simplify. And step 3, plug the value from step 2 into the original function and simplify. Now I'm going to find all the different components of this. So I'm going to work an example or find everything. No, actually, I guess I could work this one I just have here. This will make one up, but that'll work. Okay, first off, whatever number's here is your A, so that's A is 2. This is B, B is 4. And this is C, though it's not used as much. C is equal to -1. It's mainly used when you're plotting points. Now since A is positive 2, that means your graph opens up. Graph opening up also means it has a min, so we'll use that later on. Now let's take a look at our vertex formula. Step 1 of the vertex formula, identify A and B. Well, that's easy. It's given. A is 2 and B is 4. Step 2, plug these values into -b over 2a and simplify. So we'll have -4 over 2 times 2. So we got -4 over 4 or -1. Now this is the x part of the vertex. That's the x part of the vertex. Step 3, we want to take the value we just found and plug it into our original function and simplify. So I got 2 times -1 squared plus 4 times -1 minus 1. -1 squared is 1 times 2 is 2 minus 4 minus 1. That gives us -3. Now this is the y part of the vertex, which means our vertex is -1, -3. Now from the formula, symmetry looks kind of complex, but it really is just x equals whatever the x part of the vertex is. So x equals -1. We set our graph as opening up, which means it's a min, and min is going to equal to the y part of our vertex, which is -3. Now if I was doing this by hand, -1, -3, that'd be my vertex. It's opening up. I want to choose one 2 units away. And I didn't mean to choose another example, the -1, but 2 units away, we could plug in +1. Now we're going to plug that back into our original function, see what our y is equal to. So we've got y is equal to 2 times 1 squared plus 4 times 1 minus 1. 1 squared is 1 times 2 is 2 plus 4 is 6 minus 1 is 5. So this point, assuming I did my basic math right, would be 1, 5. So that'd be right there. Now you know it's got a U shape to it, so it's going to look like that. And the axis symmetry is x equals -1. So it's going to be symmetric to this, so I can flip it over and that gives me my other side of my graph, as well as I can draw it. Now if you're plugging this in your calculator, you go to y equals clear, and we've got 2x squared plus 4x minus 1, and then graph. And you see more or less gives us the same graph, if I pour more effort into sketching it correctly. But that would be our general form. Now just real briefly, create quadratic models using regression. If on your calculator, you could put in a set of data points. We talked about this, I believe, a little bit on linear. If you did sat, and you go into edit, and you got data points in L1 and L2. And I wonder if I got the same amount. I don't think these would be a quadratic form, but let's pretend they are. Then if I exit out, do a second mode after you put L1 and L2 in, L1 should contain your x values and L2 should contain your y values. Then you do stat, right arrow to calc, and then you want to choose the one that says Quadratic Regression. Press enter on it, and then enter again. Now, the closer your r squared is equal to a positive 1, the better the line is, or better the model is, I should say. This is not very good, 0.47. But if it was a decent model, we could take these values of a, b, and c rounded to whatever decimal place and plug them into this equation here. Y is equal to ax squared plus bx plus c. So this answer here would be y is equal to negative 0.18 x squared, rounded 2 decimal places, plus 8.18x minus 73.56. And that would be our model. Now let's talk about polynomial functions. And we're going to focus on the first two here, determine the end behavior and so forth. If you remember all our definitions about polynomials, I won't go into those. The YouTube video goes in more detail. But standard form means your terms range from largest power down to smallest. And so we have a leading term, which is your first term when the polynomial is in standard form. Now it's got its own coefficient, leading coefficient. This is the coefficient of the first term. And I'm going to label this as coefficient. It's a lot of coefficients, but I'm talking about the leading coefficient when I say that. We also have a degree, which remember is the largest power of x. It's a little bit more than that, but for purposes of what we're looking at, then that'll tell us. Now we have leading coefficient test. And this tells us the end behavior. What's it doing as it goes clear to the left? What's it doing as it goes clear to the right? Now we can have an even degree. We can have an odd degree. Those are our two possibilities. You can have a positive coefficient. You can have a negative coefficient. Now if you got an even degree and positive coefficient, it's up to the left, up to the right. If you got a positive coefficient odd degree, it's down the left, up to the right. If you got a negative coefficient even degree, then it's down to the left, down to the right. And if you got a negative coefficient odd degree, I always have to think this through. It's up to the left, down to the right. What's that mean? Well, let's look at an example. If we have f of x is equal to negative 2x to the third minus 7x squared plus 8x plus 1. This is in standard form. Terms range from largest power down to smallest. The only thing we ever look at is the first term, the leading term. Now I notice it's got a negative coefficient. And the power, which is also a degree, is odd. So we got an odd degree. So we go look up negative coefficient and odd degree. Negative coefficient and odd degree. The intersection of those is right here. That tells us it's going up to the left, down to the right. So up to the left, down to the right. Now some books we use a notation here. Up to the left, they'll have a little line going up like that, and then they'll have some lines here in the middle, and down to the right would look like this. This helps us to figure out how to graph something, for example. Let me erase that. Now identify zeros and multiplicity of zeros. And this goes right along with sketching a polynomial function. Let's say I had this right here. Let's see what that gives us. X minus 1, x squared plus 4x plus 4. So we got a polynomial. That's x to the third, 4x squared, 3x squared, 4x squared, 4x, minus 4x minus 4. That didn't seem right. Let's see, x to the third plus 4x squared plus 4x minus x squared minus 4x minus 4. Okay, I guess it is. Okay, now we want to determine the zeros and then the multiplicities, and then we'll sketch this. Well, first thing, we're going to set this equal to 0. Now we would factor this. Now I've chose one a poor example because we can't see how to factor it, but it does factor as x minus 1 times x plus 2 times x plus 2 equal to 0. Any they give you in the problems, you'll be able to factor probably by grouping, if I had to guess. But you'll get the idea. So we factor it. And this is x minus 1 times x plus 2 squared equal to 0. Now after you factor it, then you're going to set each factor equal to 0. So I'll set x minus 1 equal to 0 and x plus 2 equal to 0. And that gives us x equals 1 and x is equal to negative 2. Now these would be our zeros. Now the next item they're talking about is multiplicity. Multiplicity is how many of them do you have? And it goes back to your power up here. This would be a multiplicity of 2 since this has got a second power. Now I might say this other one doesn't have a power, but if we were to put a power here, it would be the first power. So that would be a multiplicity of 1. Now where this is used at, that tells us whether it touches or crosses the x-axis. When I say touches, that means it goes and touches at a point, turns around, and comes back. Crosses means it just directly crosses the x-axis. If your multiplicity is even, that means it touches. If your multiplicity is odd, that means it crosses. Okay, now I'm sketching this, let's say. Our leading coefficient test would be based upon our first term, which has a positive coefficient and an odd degree. That would be down to the left, up to the right. We know it has zeros at negative 2. Right here, and at negative 2 it's going to touch. It also has it a positive 1. And here it's going to cross. So it's going down to the left, which means that no matter graph's going down, it's coming up here, it's touching at a point. Since it's touching, it has to turn around. I didn't try to do that real well. Try it again. Coming up here, touching at a point, and once it touches at a point, turns around, comes back down. At some point it has to turn around because it has to come up here to cross. So by knowing the end behavior in the zeros, touching and crossing, we can come up with a very crude sketch of this. What we don't know is how far down does this go. We don't have an idea on that. And maybe some other points to see how much of an angle is right here. But again, that those pieces gives us a very crude sketch of it. Now in terms of the graphing, we could also graph this on our calculator. Go to y equals clear. We got x to the third plus 3x squared minus 4, and then you push graph. And you can see I somewhat have the sketch down, but it doesn't go quite down as far as I indicated. Let me clear this off. And let's talk about division of polynomials. Remainder and factor theorem. We'll grab a drink here. Okay, long division. Let's say I have x minus 3, and I have x to the third minus 7x squared plus 8x minus 2. Now for long division, two things have to be true, and I got this further documented in the YouTube video. Whatever's out in front and whatever's underneath here have to be in standard form. Terms range from largest power down to smallest, and you put 0 placeholders for missing powers. Now both of those are accounted for. Now we look at the first term of each side, what goes up on top. So you ask yourself what times x gives you x to the third, and that'd be x squared. Now whatever you put up on top, you're going to multiply by what's out in front. So I'm going to take x squared times x minus 3. X squared times x is x to the third. X squared times negative 3 is negative 3x squared. Now we're going to subtract that line, which means flip signs. So this positive x to the third becomes negative. This negative 3x squared becomes positive. X to the third minus x to the third drops away. Negative 7x squared plus 3x squared gives us negative 4x squared. And then I'll carry down everything else. And then we repeat the process. We look at the first term of each, decide what goes up on top. You ask yourself what times x gives you negative 4x squared, and that'd be negative 4x. Now whatever we put up on top, we're going to multiply by what's out in front. So we're going to take negative 4x times x minus 3. Negative 4x times x is negative 4x squared. Negative 4x times negative 3 is a positive 12x. Now we're going to subtract that line, which means flip signs. So the negative 4x squared becomes positive. The positive 12x becomes negative. Negative 4x squared plus 4x squared drops away. 8x minus 12x is negative 4x. And then I'll carry down the minus 2. And then we repeat the process. You take a look at the first term of each side, what goes up on top. You ask yourself what times x gives you negative 4x, and that'd be negative 4. Now whatever we put up on top, you multiply by what's out in front. So we're going to take negative 4 times x minus 3, which gives us negative 4x plus 12. Now we're going to subtract that line, which means flip signs. So the negative 4x becomes a positive. The positive 12 becomes a negative. Negative 4x plus 4x cancels. Negative 2 and negative 12 is negative 14. Now the degree is your largest power of x. So the degree of negative 14 is 0. And degree of x minus 3 is 1. So whenever the degree down here becomes less than what you're dividing by, this is always your remainder. And you take your remainder and you put it over what you're dividing by. And that'd be your answer. Now that's our long division or our polynomial division. Let's talk about synthetic division. And I'll actually work with the same problem. I'm going to take my x to the third minus 7x squared plus 8x minus 2, and I'm dividing it by x minus 3. Remember, a fraction indicates multiplication, or division, sorry. Now step 1. We take what we're dividing by, which is x minus 3, You set it equal to 0 and you solve it. So that gives us x equals positive 3. Now we take the number that we found in step 1 and you put it in a box in the upper left hand corner. So we'll put 3 here. Now we want to identify our largest power, which is x to the third. So real small across top, I'm going to write x to the third, x squared, x, and no x, our constant term. And then I write down whatever number's in front of them. The number that's in front of the x to the third is indivisible 1. The number that's in front of the x squared is negative 7. The number that's in front of the x is 8. And the no x, a constant term, is negative 2. Now we're going to go through a series of adding and multiplying over and over until we're done. So we start with our first column. We got 1 plus nothing, which is 1. Now sometimes that throws people. It's like, what do you mean nothing? Well, there's nothing here. If that throws you, it really is just easy as you take this number, you bring it straight down. That's the adding. Then we multiply. You always multiply by a number up in the box, by a number we just put down here. So 3 times 1 is 3. And then I'm going to add. Negative 7 plus 3 is negative 4. And then you multiply. You always multiply by a number up in the box, by a number you just put down here. So you got 3 times negative 4, which is negative 12. And then you want to add. 8 and negative 12 gives you negative 4. And then you multiply. You always multiply by a number in the box, by a number you put down here. So 3 times negative 4 is negative 12. And then you add. Negative 2, negative 12 is negative 14. When are you done? When you don't have any more columns to work with, that tells you you're done. Now this was x to the third. Straight down below here will be 1 degree lower. So this will be x squared. Now after you have your first one, then you just go down, filling it in. So this is x squared, this will be x. This will be our no x, our constant term, and this will be our remainder. So our answer will be x squared minus 4x minus 4, and then we put a remainder over where we're dividing by, which was x minus 3. And you see that gives us the same answer as what we did up there with long division. Some people ask, well, I like synthetic division because it's just adding and multiplying. That's all it really is. Yeah, it's basic math, but you can't do it all the time. The only time you can do synthetic division is when you divide by x plus a number or x minus a number. Those are the only times. Now the next topics are the remainder and factor theorems. Let me show an example of the remainder theorem. If I have f of x is equal to x to the third minus 2x squared plus x minus 1. And I want to evaluate. I want to find f of 2, for example. The remainder theorem is another way of evaluating a polynomial function. What we do with the remainder theorem is you take the number you're evaluating for, so whatever number's in the parentheses here, right here, you put in the box in the upper left-hand corner. Now we identify our largest power, which was x to the third, so real small across top. I'm going to write x to the third, x squared, x, and no x. The number that's in front of our x to the third is a 1. The number that's in front of our x squared is negative 2. Number in front of our x is a 1, and our no x, our constant term, is negative 1. Now I'm going to go through my synthetic division, so I'll add. 1 plus nothing is 1. Multiply. You always multiply by a number up in the box, by a number you put down here. 2 times 1 is 2. Then I'm going to add. Negative 2 plus 2 is 0. Then multiply. You always multiply by a number up in the box, by a number you put down here. 2 times 0 is 0. And then add. 1 plus 0 is 1. multiply, you always multiply by number up in the box, by number you put down here. 2 times 1 is 2. And then add, negative 1 plus 2 is 1. Now remember, this is x to the third, this is 1 degree lower, this is x squared, this is x, this is our no x, or our constant term, and this is our remainder. Well, the remainder theorem says we're just looking at the remainder only. This right here would be your answer. So f of 2 is equal to 1. This would be the same value as if we had plugged 2 in, evaluating a function. So if you plug 2 in, you'd have 2 to the third minus 2 times 2 squared plus 2 minus 1. 2 to the third is 8. 2 squared is 4 times 2 is 8. So that's 8 minus 8 plus 2 minus 1, which gives us 1. So it's another way of evaluating a function, specifically a polynomial function. Doesn't work any other type of functions. Now the factor theorem. Actually, I may cover the factor theorem in the next section. So I'm going to ignore the factor theorem here briefly, and let's talk about zeros of polynomial functions. I'm going to first show this by hand, for those of you who don't have a graphing calculator. Got f of x is equal to x to the third minus 3x squared minus 18x plus 40. And instructions are to find all the zeros. And it says apply the rational zero theorem. So let's talk about that first. I'm not going to talk about these last two. You can read the material on that. For the rational zero theorem, what we do is identify p and q. P's are a number at the very end, our constant term. I guess it doesn't have to be a constant. Our number at the end, whatever that term is. And then the coefficient on our first term is going to be our q. So this will be our q. So p is equal to 40 and q is equal to 1. Now with p, we write down all products give us 40. So we can have 1 times 40, that gives us 40. We can have 2 times 20, that gives us 40. 4 times 10. And 5 times 8. Now notice I put plus or minuses here. The reason why is we want a positive 40. What could give you 40? 1 times 40 would. But also negative 1 times negative 40 would also give you 40. So the plus or minuses handle all of our different sign cases. Now for 1. There's only one thing that'll give you 1. 1 times 1. And we don't repeat the numbers, so that's just our q. Now the rational zero theorem. What that says is all of our possible answers are given by p over q. So we take each value of p here and put it over each value of q. So we're going to have 1 over 1, we'll have 2 over 1, we'll have 4 over 1, we'll have 5 over 1, we'll have 8 over 1, we'll have 10 over 1, we'll have 20 over 1, and we'll have 40 over 1. Which gives us plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 8, plus or minus 10, plus or minus 20, and plus or minus 40. So this gives us all of our possible answers. Somewhere in here is our real answers. Now what we do is we take each one of these values. So I'm going to start with negative 1. And we plug them into synthetic division. So we're going to go through each one of these, plug them into synthetic division based upon our original polynomial. So I got 1, negative 3, negative 18, 40. Add, multiply, add, multiply, add, multiply, add. And what we're looking for is we're looking for a 0 for the remainder. We didn't get a 0. So I go to my next number, which is 1. And I'm going to plug it into synthetic division. So add, multiply, add, multiply, add, multiply, add. Still haven't got a 0. Go to my next number, negative 2. Add, multiply, add, multiply, add, multiply, add. Still don't have a 0. Go to positive 2. So add, multiply, add, multiply, add, multiply. Notice what we came up with. We came up with 0's remainder, assuming I did all my basic math right. Let me double check myself. Okay. I was hoping it wouldn't be too far. 0 as the remainder. Now this is what the rational zero theorem says, and I'll type it up. Now this is very specific to this process. And the rational zero theorem, you can go and read the official definition, but it says in this process, so in this process, if your remainder is 0, then you found an answer. Another name for an answer is a 0. So, since I found a 0's remainder here, whatever number's in this box is our first answer, which is b x equals 2. Now remember, this was x to the third, and this is now down to x squared, this will be x, and this will be no x. So we're down to x squared minus x minus 20 equal to 0. Why did I set equal to 0? Well, whenever you're finding zeros, you're constantly setting it equal to 0. Now this will factor using the PSD. Think x minus 5 times x plus 4. 0 factor property. Get 0 on one side, you factor the other side, you set each factor equal to 0. So I got x minus 5 equal to 0 and x plus 4 equal to 0. Which gives us x equals 5 and x is equal to negative 4. Fundamental theorem of algebra says that your largest power tells you how many answers you're going to have, how many zeros. Our largest power is the third power, so that said we're going to have 3 answers. Okay, now if I'm going to use my calculator to find the zeros. Finding zeros on a TID 384. And again, there's different types of zeros. This is specifically the polynomials. Step 1. Put the polynomial on y1, 0 on y2. Step 2, we're going to do second trace. We're going to choose intersect. Inner on first curve, question mark. Inner on second curve, question mark. And then we'll input an x value close to our answer and press enter. Then step 3, if decimals, so if you end up with decimals, use second mode to exit out, and then you do math, enter, enter. And step 4, if more answers, go back to step 2. Now let's take a look at the one we just looked at. So we'll work this problem again. We already know what our answers are. F of x is equal to x to the third minus 3x squared minus 18x plus 40. By the way, in case you're wondering, if my first answer had been out here somewhere, like 10 or 20 or 40, I would have had to do a lot of synthetic division to get up to that point. So it can be a very tedious process. Okay. So on our calculator, we go to y equals, clear, and we'll put our polynomial here. So I got x to the third minus 3x squared minus 18x plus 40. And then you have to have 0 on y2. This process does not work unless you have 0 on y2. Now if I just press graph, this is what our graph looks like. Our answers are where it crosses or touches the x-axis. And you can see 1, 2, 3, looks like -4, 2, and 5. -4, 2, and 5, which we know from doing it by hand that is the answers. Now I'm at step 2. We'll do second trace. So you push second button one time, push trace, and we want to choose intersect, number 5. So you can down arrow to it and press enter, or you can simply press the 5 to choose it. Now it'll come up and ask us for first curve question mark in the lower left hand corner. So you press enter on it one time. Then it'll come up and ask us for second curve question mark. So you press enter on it again one time. Now when it comes up and asks us for the guess, we want to input an answer close, or an x value close to our answer. We think our answer is -4, so let's put a -5. And that should be the one in the very bottom row. So I do -5 and press enter. And that comes back and gives us our first answer, x equals -4. Now, if we have more answers, which we do, then we repeat. So we'll go back to step 2, which says do a second trace, choose intersect, so I'll press 5, enter our first curve, enter our second curve. Now I said input an x value close to your answer. You can actually input what you think the answer is. I think it's 2, so we put 2 in and then press enter. And it comes back and tells us our second answer is x equals 2. Now we got another answer. So we'll do second trace, choose intersect, enter our first curve, enter our second curve. There's another way to do your guess. You can input an x value close to your answer. You can input what you think the answer is, or you can use your arrow keys to move your flashing cursor over close to the one you're trying to find. Now it doesn't have to be right on top of it, it just has to be closer to it. So you see my flashing cursor is really close to it now, so let me just go ahead and press enter. And it'll find whichever answer is closest to. And it tells us x equals 5. And that's how you find your zeros on a calculator. Now let's take a look at a little harder problem on this. I'm going to spend a little bit more time on these than some of the other ones, because this is challenging material. Okay, so let's I think this is one for the quadratic formula. Got f of x is equal to x to the third minus 4x squared plus 9x minus 10. Now if I were to do it by hand, I'd identify my p and q and go through all my possible values. And there wouldn't be that many here. Let me do one more by hand. This is my p and this is my q. So p would be 1 times 10 and 2 times 5 would also give me 10. Q, the only thing, this is a 1, the only thing gives you a 1 is 1 times 1. So then all of our possible rational zeros, rational zero theorem, says we're going to put each value p over q. 1 over 1 is 1, 2 over 1 is 2, 5 over 1 is 5, 10 over 1 is 10. So then we start plugging those in the synthetic division. I'll start with my first one, -1. And I'm looking for a remainder of 0. Remember, the factor theorem says that's our answer then. Okay, so we'll add, multiply, add, multiply, add, multiply, add. That doesn't work. Go to 1. Add, multiply, add, multiply, add, multiply, add. Usually the synthetic division, the one that I'm looking for, is the one I screw up on. I'm doing it by hand. Add, multiply, add, multiply, add, multiply. And at the point where you see it's not going to give you what you're wanting, then you could even stop and just go on to the next number. Add, multiply, add, multiply, add, multiply, add. Okay, let me double check that. Add, multiply, add, multiply, add, multiply, add. Notice we got a 0 as a remainder. That means we found our first answer. The number in the box here is our first answer, x equals 2. Now this was x to the third. This will be 1 degree lower. This will be x squared, this will be x, and this is our no x, our constant term. So we're going to have x squared minus 2x plus 5 equal to 0. Now this does not factor, so I have to use the quadratic formula. A is whatever's in front of our x squared, which is the invisible 1. B is whatever's in front of our x, which is -2. And C is our number at the end, which is 5. Remember, our quadratic formula is -b plus or minus square root of b squared minus 4ac all over 2a. So we got x is equal to -2 plus or minus -2 squared minus 4 times a times c all over 2a. Negative gives us a +2 plus or minus. -2 squared is 4 minus 4 times 1 times 5 is 20 over 2. So we got 2 plus or minus square root 4 minus 20 is -16 over 2. Square root of -16 is 4i over 2. And then we split it up, the real part separate from the imaginary part. And we end up with 1 plus or minus 2i. Fundamental theorem of algebra says your largest power tells you how many answers you're going to have. It doesn't say they're all going to be real. You could have imaginary answers. You could have them all the same. You could have x equals 2, x equals 2, x equals 2. All it says is if you got the largest power is 3, you're going to have 3 answers. It says a little bit more than that, but that's where we'll use it for this process. Now let's show this on the calculator. So I'll work it again. Get f of x equal to x to the third minus 4x squared plus 9x minus 10. Grab a drink here. Put our polynomial on y1. So we've got x to the third minus 4x squared plus 9x minus 10. Now if I do second trace, choose intersect, when it comes up for first curve, you press enter on it. Comes up for second curve, you press enter on that. It looks like our answer is 2. Looks like crosses a 2. So let me put 2 in for the guess and see if it is 2. So calculator told us it was 2. Now since we didn't get all of our answers via the calculator, we have to take whatever answers we came up with and plug them into synthetic division. Okay, remember this is x to the third. So add, multiply, add, multiply, add, multiply, and add. Now notice we get 0's remainder. That means we found our first answer, which is no surprise. The calculator told us there's going to be an answer, so you have to get a 0's remainder. Now this was x to the third. This will be 1 degree lower, so this will be x squared, this will be x, and this will be no x. So we're left with x squared minus 2x plus 5, and I set it equal to 0. Well, why do you set it equal to 0? Well, when we're finding zeros, we're constantly setting items equal to 0. Now notice at this point, x squared minus 2x plus 5 equal to 0, it's the same thing we came up with here by hand. So if I were to go through this process, I'm not going to, but we get the same value as the first method. So we get x equal 1 plus or minus 2i. And those are our three answers. Remember, the plus or minus means you got two answers there. You got 1 minus 2i and you got 1 plus 2i. Now let me show one more of those. Let me see. This is, I think this is the one I want. No, this is the one I want. So let me clear this off. I won't show another one by hand. I think you got the idea. Okay, so we got f of x is equal to x to the fourth minus 6x to the third plus 30x minus 25. Well, let's first go to the calculator and see what kind of answers we can come up with. So go to y equals clear x squared 4 minus 6x to the third plus 30x minus 25. And we still have a 0 on y2, so that has to be there. So let's do second trace, choose intersect, 5. Appears like we have 4 answers here, because it crosses the x-axis in 4 places. If I do inner first curve, inner second curve, and I think the first answer is -2. So if I put -2 in, we get a decimal. That's okay. The steps I gave you actually account for decimals. I said if you have decimals, you exit out, you do second mode, and then you press your math, enter. And it doesn't change. We can't use decimals if they won't change to a fraction. So let's go find our next answer. We'll do second trace. Let me put this up here. Choose intersect. Next answer looks like 1. So we do inner first curve, inner second curve, and I put 1 in for the guess. And it comes back and tells us x equals 1 is our first answer. Next one looks like 2. So let me do a second trace, choose intersect, enter, and I put 2 in. 2.236068. Well, we know how to handle decimals, so we'll exit out, do second mode, and then we'll do math, enter. That doesn't change to fractions. We can't use that. Well, we'll repeat. Second trace, choose intersect, enter a first curve, enter a second curve. This next one, 1, 2, 3, 4, looks like 5. So we'll put 5 in for the guess. And it comes back and tells us the intersection is x equals 5. Well, it would have been nice if we found all of our answers via the calculator, but at least we found 2. So what we're going to do is we're going to plug those into synthetic division. So I got 1, -6, 0, 30, -25. I get lazy about it after the section dealing with synthetic division, but if you write down your powers, our largest power is x to the fourth, then we'll have an x to the third, we'll have an x squared, we'll have an x, and we'll have our no x. You make less mistakes if you write down on every problem. because then you notice that your x squared is missing, so you have to put a 0 placeholder. Okay, add, multiply, add, multiply, add, multiply, add, multiply, add. Now notice we got a zeros remainder. That means we found our first answer. So whatever number's in the box here is our first answer. This was x to the fourth. We're now down to x to the third. Now what you want to do is you want to plug your second answer in the line we just found. So it's a continuation of that process. So then we'll add, multiply, add, multiply, add, multiply, add, and notice we get another 0. That means the number in this box is our second answer, x equals 5. Now this was x to the third, so now we're down to x squared. Each power you find takes it down one more power. Or each answer you find takes it down one more power. So that's x squared, this will be x, and this will be our no x. So we're left with x squared minus 5 equal to 0. Now whatever your middle term is missing here, square root property is going to be your easiest method. So we'll take negative 5 over. So we got x squared is equal to 5. And square root property says if you got something squared equal to something else, you drop your squared and you put a plus or minus square root on the other side. Now the reason why they were decimals that would not change to fractions is because they were really radical answers. Now our largest power is x to the fourth. We said we're going to have 4 answers. So we had 2 here, and this plus or minus counts for our other 2 answers. Okay, that's the fundamental theorem of algebra. And Descartes' rules of signs and upper and lower bounds, those help if you're doing it by hand. They help to limit which possible answers you need to even consider. Okay, let's talk about rational functions. And we're going to talk about vertical, horizontal, and slant asymptotes, and then the graph of those. We have something called an asymptote. This is an invisible line that your graph will skim at some point. You get really close to it, but never touch it, never cross it. Just keep skimming it forever at some point. That doesn't mean that somewhere else your graph might not actually cross it. In some cases we see that's true, especially with the horizontal asymptote, not with the vertical. And slant, I don't know, I can't think of any examples, but I don't think it'd occur with slant, but I'm not sure about that. Now to find our vertical asymptotes. Step 1, we would factor the top, factor the bottom. Step 2, cancel if possible. And step 3, set the denominator equal to 0 and solve. So set the bottom equal to 0 and solve. So if I had, let me make up one. Got f of x equal to x minus 3 over x squared minus 5x plus 6. And instructions are to find a vertical asymptote, although you could have more than one. Step 1, factor the top, factor the bottom. The bottom factors as x minus 2 times x minus 3. Step 2, cancel if possible. Notice how we have an x minus 3 here and x minus 3 here. Those are going to cancel. So we got 1 over x minus 2. And then step 3, set your denominator equal to 0, set your bottom part equal to 0 and solve it. So take negative 2 over and we get x equals positive 2. I don't know much about this graph at this point, but I do know that it has a vertical asymptote of 2. Okay. This is our vertical asymptote. Let's talk about our horizontal asymptote. Now, a rational function means single fraction, and degree is the largest power of x, remember? So we got a degree of the top and degree of the bottom. Now we're going to have three cases. Case 1, the degree of the top is larger. That means there is no horizontal asymptote. Case 2, the degree of the top. As far as I get older, I write more and more like Yoda off of Star Wars. I don't know if I sound more and more like him. Case 2, degree of the bottom is larger. Your horizontal asymptote is y is equal to 0. In case 3, the degrees are the same. Same are the degrees. Yeah, poor imitation, I know. Okay, I'm going to do an example, and I'll make it large so you can actually see it after I get done typing it. Let's say I have f of x equals 4x to the third minus 7x plus 1 over 5 minus 3, let's see, 5, 6, no, 7, 8, 9, x to the third. Your horizontal asymptote would be y equals 4 over negative 9. Okay, degrees are the same. Degree of the top is 3, degree of the bottom is 3, so the degrees are the same. What you do is you create a fraction, y equals, and you take the coefficient off the leading term. You take a number from in front of x to the largest power, and you create a fraction out of that on top and on the bottom. So I took the 4 off the x to the third, put it here, and I took the negative 9 off the x to the third and put it here. And now it would be our horizontal asymptote. Now if we go to this example we've been working here, that was our vertical asymptote. Now a horizontal asymptote. Degree of the top is 1, degree of the bottom is 2. So degree of the bottom is larger. That tells us our horizontal asymptote is y is equal to 0. How does this come into play? Well, I know that I have a vertical asymptote of 2. And I sure can't draw a straight line very well. I think you get the idea though. And a horizontal asymptote of y equals 0, which happens to correspond to our x-axis. So I know it's skimming these lines at some point. Now if I were to find my intercepts for our x-intercept, you always plug 0 in for the other variables. So to find the x-intercept, I plug 0 in for y. Now remember, f of x is the same as y. So I get 0 is equal to x minus 3 over x squared minus 5x plus 6. Whenever you're working with rationals and you're solving and you got a single fraction equal to 0, you can just set your top part equal to 0 and solve it. It'll always work that way. So take negative 3 over, and we get x is equal to positive 3. So our x-intercept would be right here. Now our y-intercept. You plug 0 in for the other variable, so plug 0 in for x. So this is y equals 0 minus 3 over 0 squared minus 5 times 0 plus 6. That's negative 3 over 0 squared drops away, negative 5 times 0 drops away, and we've got 6. So that gives us y is equal to negative 1/2. Y is equal to negative 1/2 would be right here. Now you have to figure out how to draw these, and that's sometimes a challenge. We got this right here, And there's no x-intercepts over here. Now, since there's no x-intercepts over here, then that would tell us that it has to skim here and skim here. So maybe it looks something like this. Now on this side, this is where we said our x-intercept was. This can be a little bit tricky over here. I'm going to graph this on the calculator just so we can see it. Put parentheses on top, parentheses on the bottom. That's how you plug them into the calculator. So if I go to y equals, clear, beginning parentheses, x minus 3, closing parentheses, divided by, beginning parentheses, x squared, minus 5x, plus 6, closing parentheses, and then graph. You see I got that right there. Okay, I don't have an x-intercept of 3. Better get more sleep at night. I'll blame it on the reason why is not defined in our original domain. In the interest of time, I was skipping the domain. But if I plug 3 into my original problem, you got 3 squared, which is 9, minus 5 times 3, which is 15. 9 minus 15 is negative 6, plus 6 is 0. So this causes the original function to be undefined. Okay, so we don't have that there. So at this point then, this would have to, it wouldn't have to I guess, but for the simpler problems it's up here. And the reason why is that this piece is down here, that they're usually follow some kind of pattern like that. This is down here, this will be up here. And you can see that from the graph here. I didn't even see that about the domain. But that would be our graph. Now, again, it's an invisible line. Your graph will skim at some point for the asymptotes. Okay, let me clear that off. There's something called a slant asymptote also. I think I got time for that. That might be the last item. Your slant asymptote. Some books call this the oblique asymptote. This, you have this, the degree of the top must be exactly 1 larger than the bottom in order to have a slant asymptote. And what you do is you use long division and drop the remainder. So make up one. F of x is equal to x squared minus 3x plus 1 over x minus 2, I guess. First off, I know it has a vertical asymptote, x equals 2, if I were to go through that. So it looks like this. Now find our slant asymptote or oblique. We're going to use long division. So we take our first term of each, and you ask yourself what times x gives you x squared, and that'd be x. Now whatever you put up on top, you multiply by what's in front. X times x is x squared. X times negative 2 is negative 2x. We're going to subtract that, which means flip signs. So this becomes negative, this becomes positive. X squared minus x squared drops away. Negative 3x plus 2x is negative 1x, or negative x. Now bring down to plus 1. And then you look at the first term of each side, what goes up on top. You ask yourself what times x gives you negative x, and that's negative 1. Now, whatever you put up on top, you multiply by what's up in front. Negative 1 times x is negative 1x, or negative x. Negative 1 times negative 2 is a positive 2. Subtract that, which means flip signs. Negative x plus x cancels. 1 minus 2 is negative 1. And drop the remainder. This is your remainder, so that goes away. So your slant asymptote is y is equal to x minus 1. What that means is I'm going to have a invisible line that's y is equal to x minus 1, and my graph skims at some point. Now, if I were to find my intercepts, 0, negative 1/2 would be right here. My x-intercepts, I don't know. I'd have to use Quadratic Formula on it. But this part would look like this. And it's a pretty good bet that if it's like this, your next part would either be up here or down here. And just based upon them following some kind of pattern, I'm guessing it would look something like this. Now, where would it cross, so forth, I don't know. If I put parentheses on top, parentheses on the bottom, let's see what it does look like. Let's see. Beginning parentheses, x squared minus 3x plus 1. Close parentheses divided by beginning parentheses x minus 2. And then graph. And more or less that looks correct. But that's, again, slant asymptote is used to help come up with the graph. And let's see, graphing, identify slant asymptotes. Okay. Now, the next topic I really don't have time to cover, so I'll just refer to you for section 3.6 and 3.7 to look at the YouTube videos I put out there. And that's true throughout. If you need more intense examples, go out there and look at those. So I'm going to go ahead and stop the video there, and or stop the recording, and then I'll answer any questions you have.